Last day of new notes, talking about expanding and condensing. So hey, if this is our last day of new notes, we should probably have what soon? Test. So here's our plan for the rest of the unit. Today, new notes, expanding, condensing. Tomorrow, review. Monday, review. Tuesday of next week, we will be having a test on Unit 4 logarithms. After Unit 4, we said we were going to have a what? Midterm. So we have our test on Tuesday. Wednesday and Thursday will be review for the midterm. Next Friday will be our midterm exam.
Is it multiple choice?
It is multiple guess, yes. Alright? So, test Tuesday, midterm exam Friday. We understood?
Yes, sir.
Alright, awesome. Let's talk about our lesson. Expanding condensing logarithms. So, remember, a log is an exponent. So we talked about that on the first day. We can switch it from exponential to log form to exponential. Which means that exponent rules can be applied to logarithms to create the following properties. We're going to have three properties. The first one is that a product, the log product is equal to the sum of the logs. What that means is if I'm taking the log of m times n, I can take it, I can split that into two separate logs and add them. The log of m plus the log of n. Just like with my exponent rule. When I multiply things at the same base, I added their exponents. Same things with logs. When I'm multiplying, I can add. Alright, and we're going to go both ways, guys. We're going to expand it out to addition. We're going to condense it down to multiplication. Division. M divided by n will turn into the difference of logs, or subtraction. Log of m minus log of n. We'll go both ways with that. Then also, base to a power becomes power times the log. So if I have an exponent, I move it out front, and it's multiplied by my log. Now, all three of these rules will be used. Yes, you need to know them. Obviously, I don't expect you to have them memorized this second, so when we do some examples, we'll have them on that first page. We'll work through it. We're going to work both ways. We're going to go expanding it, which will be making it longer, or we're going to go condensing it, which will make it down to one logarithm. Alright, the biggest thing, multiplication turns into addition, and vice versa. Division turns into subtraction, vice versa. And a power turns into multiplication out front, turns into a number out front. Alright? This probably means absolutely nothing to you right now. We'll do some examples, it'll be better. Promise. Cool? Okay. Or do we all have that written down? So those are fill in the blanks, I believe. Okay. No? Give you a couple seconds to write it down quick. All time in the world. Ready? Okay. So we were talking about expanding. So we want to write these logs in expanded form, which means we're going to take any multiplication, turn it into addition. Take any division, turn it into subtraction. Take any exponent and move it out front in front of the log. So here's our three rules here. Our first problem, if you look at it, says log of 5xy. In other words, log of 5 times x times y. Do I have any exponents I need to deal with?
No.
Do I have any multiplication or division?
Multiplication.
I have multiplication of all three of these terms. 5 times x times y. What's going to happen? When I expand it, I'm going to turn that into addition. And each one of these pieces, 5x and y, is all going to get its own logarithm. So this become the log of 5 plus the log of x plus the log of y. Right? Each one of those pieces is its own log, and I'm turning it into addition. I'm expanding it. Right? Expanding means to get bigger. So I'm making this, and it's becoming bigger. Now, when we have variables and stuff, it really doesn't make a lot of sense why we do this. When we have certain numbers, sometimes it's easier to actually do all the different logs in smaller pieces and add them all together. Right? So that's kind of why we do it. We use these rules to do that. The second one, right? That's it. I'm done. No more multiplication, no more division. That's fully expanded. The second one, the natural log. of 2 times x to the third. Do I have any multiplication or division to deal with?
Multiplication.
I have multiplication, right? 2 times x to the third. Multiplication is going to turn into addition when I expand. So it becomes the natural log of 2 plus the natural log of x cubed. Right? Splitting up into each separate piece. Notice, the base I begin with, whether it's natural log, whether it's log, will be the same base throughout. So if I have like log base 2 to start with, every piece should be log base 2. It should be the same base at the end as it was at the beginning. Now, I have not done with this one yet. I have an exponent. And when I'm expanding, that exponent gets moved out front. So I'm taking this 3, move it out front, turn it into a product. The natural log of 2 plus 3 times the natural log of x. And that's my final answer. I have no more multiplication or division in there, and I have no exponents. Alright, let's try the third one. The natural log of 3x divided by y. Well, multiplication or division? Do I have either one? I heard someone say it. Division. Now, I'm going to do the division first. I actually have both, right? 3 times x is also multiplication. But I'm going to do the division first and worry about the multiplication second. Division, if I look at my 3 rules, turns into what? What is this? Subtraction, right? So I'm going to take my numerator, will always be listed first, log of 3x minus log of y, right? My numerator minus my denominator. Then I said I had multiplication. So what's going to happen is my multiplication is also going to turn into addition. I need to expand it completely. So it becomes log of 3 plus log of x minus log of y. Right? This multiplication expands out to addition. Now, I like to put parentheses around those sort of things so I know, hey, I got to combine that back first before I can combine it to division. You don't necessarily have to do that, but like I said, I prefer to do it that way, where I put parentheses around it. And that's my final answer. Any questions on the expanding part of it? Does it make even a smidge more sense? Even just a little bit. Okay. Let's try going the other way. Let's try condensing it. So condensing is going the opposite way. Now I'm looking for numbers out front to turn into exponents. I'm looking for addition to turn into multiplication. I'm looking for subtraction to turn into division. My first problem, log x plus log y minus 2 times log z. Are there any numbers out front that I can turn into exponents? Any of those logs have a number it's being multiplied by? Which one, Grace?
2.
2. Right? I'm going to take this 2, and it's going to become an exponent for whatever I'm taking the log of. In this case, it's z. So it becomes log x plus log y minus log z squared. Now I'm going to keep going towards my goal. Guys, when we condense, our goal is to get it down to one logarithm, one single logarithm. Okay, my next step, I'm looking for, do I have any addition or subtraction? Yeah, right? I'm going to deal with the addition first in this problem. My addition, if I go backwards from those rules, addition is going to turn into a multiplication, right? Multiplication turns into addition, so addition turns into multiplication. So I'm going to multiply what I'm taking the log of in these 2 pieces. Becomes log of x times y minus log of z squared. Alright, then my next step, that's subtraction. What do you think subtraction is going to turn into? division, right? Division turned into subtraction, so it's the same going the other way. My numerator will always be the first term. So this part will always be on top. Log of x times y divided by z squared. And if you want to, you can put it in parentheses, but you do not have to. And that is my final answer. It's condensed all the way down to one logarithm. We did our job. Alright, that was the first one. Let's look at the second one. The natural log of 5 minus the natural log of 8 minus the natural log of x. Do I have any numbers up front that turn into exponents? No. Do I have any addition or subtraction? Yeah, I have subtraction, right? So I'm going to take it one piece at a time here. I'm going to look at this first subtraction. I know I'm going to turn this into division. So it becomes a natural log. 5 divided by 8 minus the natural log of x. Now, does 5 divided by 8, does that give us a nice number when we do that? No, so do you think I should leave it as a rounded decimal? No, leave it as a fraction. If it's not a nice number, leave it as a fraction. Alright, well what's this other subtraction going to turn into? Division again, right? Subtraction is into division. So it becomes natural log 5 divided by 8 divided by x. Have we ever seen anything like that in math? No. Now, instead of doing that, because that looks really ugly and we would never do that, right? If I had 5 over 8 and I wanted to divide by x, let's say over 1, what could I do instead of dividing? Does anyone remember? You have learned this.
I know. I think I know what you are, but what you're trying to do, but I know what it's called.
You don't know what it's called. Can you tell me what you want to do though? You don't even know the name. What would I do?
Something where it's crossing or something maybe.
I'm not going to cross multiply.
Subtract.
Not going to cross multiply. Is it going to end up being the same result as cross multiplying? No, not the same. I lied. Not the same as cross multiplying. But you are on the right track. We are going to multiply by something. You guys remember doing keep, change, flip?
No.
No? You never heard it like that? What about like multiplying by the reciprocal? Yeah, right? When we're dividing fractions, we're going to multiply by the reciprocal. We call it keep, change, flip because you keep the first fraction, you change division to multiplication, and you flip the second fraction. So in other words, we are multiplying by the reciprocal. So instead of dividing this by x, I'm going to multiply by 1 over x, which 5 times 1 is 5. 8 times x is 8x. So instead of writing it like this and ugly and getting it marked wrong if I wrote it like that, I'm going to write it as the natural log of 5 over 8x. That's my final answer. Yes, ma'am.
Can you just add the variable into the denominator then? Or should you show your work first?
I mean, if you can go right from here to there, go ahead. Okay? Alright. Any questions on those first two? Okay, let's run through the third one quickly. 3 times log x plus 4 times log y. Any numbers out front to turn into exponents? Do I have any?
Yes.
Yeah, I have a 3 and a 4 that I can make exponents. That's the first step. So I get log of x cubed plus log y to the 4th. Okay, so I did that. Any addition or subtraction?
Addition.
Addition, which is going to turn into
Multiplication.
multiplication. So log x cubed y to the 4th. And that's fully condensed. I'm on one log. Okay? Does it make a little more sense now? Yeah? Alright, there's a lot of problems to do, but we do not have a lot of time. So I'd like to give you some time to work on your homework. So what we're going to do is we're going to do one from each of those. Alright? Expand the following. Bailey, Pick A, B, or C, please.
A.
A. All right, we'll do the first one. The first one, expand the natural log of x over w. Any addition or, not addition or subtraction, multiplication or division. Division. And that turns into subtraction. So when I expand this division to turn into subtraction, I get the natural log of x minus the natural log of w. The numerator minus the denominator. Do I have any powers that I need to move out front? No. Do I have any other multiplication or division? No. So I'm all done. That's it. That's expanded. Okay. What? The next one only has two problems, right? Let's try condensing. Jackson, pick A or B, please.
A.
A. We'll do A again. All right. 2 log x plus 3 log y minus 4 log z. Any numbers out front that I can turn into exponents? Yeah, right? I have a 2, turns into an exponent. 3 turns into an exponent. 4 turns into an exponent. I get log x squared plus log y cubed minus log z to the 4th. That's the first step. Second step, multiplication, addition or subtraction. Sorry. Any addition or subtraction in there? Yeah, I got both, right? I'm going to do the addition first, and then I'll do the subtraction. So addition turns into multiplication. I get log of x squared y cubed minus log z to the 4th. One last step. I gotta get rid of that subtraction so I can combine it down to one log.
Division.
Turns into division. Very good. So I get log x squared y cubed over z to the 4th. Down one log. That's my final answer. All right. Any questions on expanding, condensing, those sort of things? All right, I want to do one more problem, right, from the next row. This is when we're evaluating. Do we have that written down? Can I move on? Guys, if it ever asks you to evaluate the expressions like this on a test, what are you going to do?
Evaluate.
Evaluate them. How are you going to do that?
Evaluate.
Put them in your calculator, right? Do you have to do this expanding, condensing sort of stuff with these? No. We're going to do it with one of them just to show you why it might be easier to do it in some instances. But if you get something like this in your test, put it in your calculator. That's perfectly fine. Do that. All right? Okay. I want to do B. The natural log of E cubed. If I use my expanding rules, what can I do to that? Anybody? What? 3 times the natural log of E. Right? Because if I look here, I have an exponent. My expanding rules tell me I can move that out front. 3 times the natural log of E. Well, does anyone remember when we started natural logs, we started base of E, we started talking about E? What the natural log of E will always equal? Go ahead and put it in your calculator once. Do natural log of E to the first power. Natural log of E to the first power. 1? 1? Everybody got 1, right? That is because log base E is the same as the natural log. Log base E of E. Remember, when we said these two numbers match, it will always equal 1. So the natural log of E is always 1, and 3 times 1 would be 3. So sometimes it might be easier to use some of those rules, but if you have your calculator, you can just put it right in your calculator. All right? Cool? Any questions? Sweet. That's it. We're done. Hey, do me a favor. Use the button, that silver button that stops the recording on it.